And I just got the pop-up notice. I got it. Okay. Okay, folks. So if you remember last time, what we did was we took a look at this quantitative data, right? And correct me if I'm wrong, folks, but what we did was we went through and we were able to construct a frequency distribution using Sturge's rule. And then we got to the histogram, all right? And I think we left off there. I don't think we got to the frequency polygon, the stem and leaf diagram, and the dot plot, okay? So that's what we're going to do today to start with, okay? We're going to go ahead and start by constructing a frequency polygon, a stem and leaf diagram, and a dot plot for the exam data, all right? Now, before I do that, I am going to need your folks' help. Because I'm going to reconstruct the frequency distribution that we had from before. So, and realistically, all I need is I just need the frequencies. I don't need the relative nor the cumulative frequencies. Okay, so just give me one sec. And switching over here. So if you guys recall, we had our classes. Okay. And then from our classes, we also had the frequency. Okay. And can somebody remind me, I think the first class we had, I think that the width was the width 8. I think it was like 8.34. And so I think, correct me if I'm wrong, the first one went from 61 up to 60, what was it, 68, folks, I think. Okay, got it. Okay, thank you. Okay, and then we had from 69 to 76, I believe, right? And then I think from there, we just kept adding 7 each time. Okay, so we had 77 to 84, and then I think we had 85 to 92, and then I think we had 93 to 100. Okay. And then can somebody remind me what the frequencies are? I mean, I could certainly count them, but so it was 2, thanks for 1, and then 5, and then 2, and then 3, I think. Right. Okay. Thank you. Good stuff. Okay. And so one of the next things that I think I asked you all to do with this problem is to be able to construct something called a frequency polygon. Okay, so let me show you how to do that. It's actually pretty easy to do. Okay, and what you're going to do is you're going to have the same axes as you did for the histogram. Okay, but instead of having the bars, okay, what you're going to do is you're just going to put a dot at the frequency. Okay, so for instance, so we would go up to 5. Okay, so 5, 4, 3, 2, 1, and then we would label this. Okay, so just call this the frequency. Okay, and sorry, I'm a little bit limited with respect to where I can write, so I do apologize. All right. And then from there, what we would do is we'd say, okay, well, in the class from 61 to 68, we just put a dot where the height of the frequency is. Okay, so right there. Okay, and then for the next one, we had 1, so I'm going to put a dot down here. And we're going to say that that's going to be our 69 to 76. Okay. And then we just keep doing that. Okay. So we have 5 up here. Okay. And that was for our 77 to 84. All right. And so I'm running out of room, obviously. So I'm just stacking these up. And then 85, 92. All right. And that's going to go for 2. And then finally, there were 3 folks that got the 93 to 100. Okay. And then the last thing we do is we just say that these are grades. That's supposed to say grades down there somewhere. And then, of course, we need a title for the graph. And so the title would be, I think it was Math 216 Final Exam Grades. Okay. The last thing you're going to do with the frequency polygon is you're going to play connect the dots with this. Okay. And so what I mean by connect the dots is do something like this, where you just draw a line here, 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 and here. Okay. And similar to what we talked about with cumulative frequency, this helps us to see like rates of change. Okay. So for folks that are you know, for statisticians and people that are really into rates of change, okay, people that do optimization, that's where something like this would be helpful. Okay, but for most of the time, the histogram is a little bit better way to go. But you know, this is another way to graph things. Okay, so folks, any questions I can answer for you all about how to construct a frequency polygon? Okay, if you have questions, either drop them in the chat or just shout them out loud. All right, folks. Next thing I want to show you all is the stem and leaf plot for this. Okay. So for a stem and leaf plot, we don't need the frequency distribution. Okay, so hold on one sec. Let me move to another page. All right. So for a stem and leaf plot, it's going to have a column for stems and a column for leaves. Okay, so when I do this, this is going to be my stem, and these are going to be my leaves. Okay. Now, when I talk about the stems, that's going to be the first digit or digit places of your values. So notice like the data that we have, if you're looking at the guided notes, we have 61, 65, 70, 79, etc. Okay, so the stems that we're going to have are 6, 7, 8, 9, and 10. Okay. And what these represent is the numbers 60, 70, 80, 90, and 100, those digit places. Okay. So if somebody got like a 30, we would have a stem of 3 in there. All right. Now, here's the way I'm going to fill out the leaves problem. I want you to notice that there's a 61 and a 65. So what I'm going to do is I'm going to write in a 1 and a 5, all right, in the leaves column. And so what that represents is I see that somebody earned a 61 and then somebody earned a 65. Okay. And so that's how we go through and try to work one of these sorts of stem and leaf diagrams. Okay. So we have 3 leaves that we would use for 70. Okay. And notice there's repetition. Okay. In that 9. So you would say 0, 9, 9, 9. Okay. So anytime there's multiple instances of the same observation, you just copy down the numbers again and again and again. Okay. For the 80, 1, 3, 7. For the 90s, there's a 92, a 95, and a 98. And then there's a 100, so I'm going to put a 0 at that last space there. Okay. What this does, somebody might be thinking, okay, well, why would I ever want to use this thing? Well, number one, it's a pretty quick way to see where the majority of the data lies. Okay. Number two, if you were to rotate this thing about 90 degrees, it would actually turn into a sort of like a rudimentary histogram. Okay, so it's just a quicker way to do a histogram. It's not as scientific, it's not as accurate. But what we can see is that the large majority of the data falls between 70s, 80s, and 90s. Okay, there's a few people that got 60s, and there's a person that got 100. But from this graph, we can clearly see that the large majority of the observations are between 70 and 90. Okay, or something of that nature. Okay. All right. So any questions, folks, about how to go through and construct a stem and leaf plot? And we are going to do another example of this. So if you didn't understand it this time, in our secondary example, I'll try to illustrate as well. So questions, folks? Everybody okay thus far? Okay. All right, folks. Last sort of diagram that I want to make sure you guys understand is a dot plot. Okay. Dot plot, again, is really easy, and we don't necessarily need the frequency distribution for this. Okay, so for our dot plot, okay, we're just going to draw a number line or a number curve in my case, because I'm trying to write on my surface. And I'm just going to plot the values. I'll just say 60, 70, 80, 90, and 100. Okay, and these are Math 216 grades. And what I'm going to do is I'm just going to put a dot above the axis, not on the axis, but above the axis where each of the observations lies. So right here, I'm going to put a dot, and that just represents that we have a 61. Okay. And then notice that I have a 65. So I'm going to put a dot just next to that. I have a 70. So I put a dot here. Okay. And then I have 3 79s. Okay, so if you have multiple instances of the same observation, what I'm going to do is I'm going to just stack these up. So there's a 9, a 79, and a 79. Okay, so again, anytime you have repeat instances, you just stack them up. Okay, then we have an 81 and 83. All right, and then we have an 87. All right, and we're just going to approximate these. Okay, we're not going to like get a ruler out or a protractor or anything like that. Okay, and then we have like a 92 and a 95 and a 98, and then finally 100. Okay, all right. So that's how we do our dot plot, folks. Okay, so no, not meant to be too difficult. Okay. All right, so before we finish this example, okay, any questions I can answer about being able to work with histograms, frequency polygons, stem and leaf plots, dot plot, okay, or the frequency distribution for quantitative data. So let me check the chat really quickly, make sure there's nothing in there. Okay. Okay, folks. So next thing we're going to do is we're going to give some characteristics to some of our histograms. Okay, so just bouncing back really quickly over here. So we're going to talk about different ways to characterize our quantitative data. Okay, and what I'm usually going to do is I'm going to ask you all how to go through and try to characterize the graphs, okay, mostly the histogram, okay? A little bit later in the class, when we start talking about box plots, I might ask you to characterize those box plots, okay? All right, so for instance, sometimes we're interested in the number of distinct peaks in the data, okay? We call that the shape of the data, okay? So hold on a sec, got to enable editing. Now I have to go all the way back down. Thanks, technology. So the shape of the data describes the number of distinct peaks in the graph. Okay. There's something called the center. Okay. And that's where the large majority of the data lies on the graph. Okay. And then finally, there's something called the spread. Okay, so we have a shape, a center, and a spread of a graph. Okay, and these are the three characteristics that we're looking for specifically on histograms for the most part. Okay, not just the histogram, but most times we want to describe the shape, center, and spread. Right now, each of those terms has its own subset of terminology attached to it. All right, so when I talk about the shape of a graph, if it has one distinct peak, that's unimodal. Okay. If you look back at the histogram that we constructed on Wednesday, that was a unimodal graph because it had one peak, and I think the value was at 5, right? I think the highest number of observations was 5 for that, okay? So again, if we have one peak in the data, that's unimodal. If we have 2 peaks in the data, we call that bimodal, okay? Bimodal graphs happen a lot in real life, okay? So for instance, a bimodal graph might happen with the average heights of human beings, okay? Because usually we have an average height for females and then an average height for males, all right? And then average height in the United States for a female is about 5'4". Average height for a male is about 5'10". So there's like, those 2 distinct peaks on those averages, okay? So that would be like a real life example as to where somebody could say that they're looking at bimodal data, okay? If it has more than 2 peaks, we just call that multimodal. Okay. And then finally, if it has no peaks, we call that uniform. Okay. And in a few moments, what I'm going to do is I'm going to go through and ask you all to characterize some graphs, okay, by using these phrases. Okay. But for right now, we're just giving out the definitions for these. Okay. All right, so folks, any questions I could answer so far about shape, center, and spread, and then the definitions of shape? Everybody good thus far? Oh, or good enough? All right. With the center of a graph, okay, now the center is backwards. If most of the data occurs on the right, we say that that's skewed left. Okay, so a graph that's skewed left, there's more data that occurs on the right side of the graph. Okay, so Just because math people, we like to mess with, people that aren't math minded for the most part. So we have to have our own lexicon and our own language. Okay. If we want all the data, if for some reason we have a graph where the majority of the data occurs on the right, we say that's skewed right or left. That's going to be skewed to the right. Okay. So if more data is on the left, it's on the right. And then if for some reason we have a graph where more data occurs in the middle than it does on the end, we call that normal. Okay, and some of you have probably seen the normal distribution before, or the bell curve. Okay, so, and we're going to see that later in the course. Okay, in fact, you're probably going to wish you never saw it by the time we're done with it, of course, we're going to use it so much. Okay, all right. Now, last thing we do is we look for a spread or any gaps in the data. Okay, so an observation that strays from the majority is called an outlier. Okay. And the spread of a graph identifies if an outlier is present or not. Okay. So realistically, what we're looking for is we're just looking for gaps in our histogram or gaps in the data. So any gaps in our histogram. All right. That's usually a good indicator that there's going to be an outlier. Okay. Or it could be gaps in your stem and leaf plot or gaps in your dot plot, whatever it might be. Okay, whichever graph you're looking at. Okay, but anytime you see this observation that's really far off. Okay, and so for instance, I'll give you an example of an outlier. Okay, if I asked everybody to put their age in the chat, which I'm not asking you to do, and then I put my age in the chat. Okay, I suspect I don't want to say significantly older, but I would suspect I'm an outlier compared to the large majority of the class. Okay, so just think of it in that terms, like with an outlier. Or let's say if I asked you all, I think I asked you all on Wednesday to talk about or to give me the number of credits that you've earned at Harvard. And then what if I put the number of credits that I've earned throughout my academic career? Okay, I'd certainly be an outlier because I have over 170 some credits that I've earned. All right, so that's an example of an outlier. Okay, outlier is something that, it probably signifies that it doesn't belong in the set of data. Okay. All right. So what I'm going to do is I'm going to give you guys 3 graphs. Okay. And you're just going to tell me what the shape, center, and spread of that graph is. Okay. And I'm just going to use a histogram each time I do this. Okay. So for the first one that we have here, okay, we have this sort of shape that's going on. Okay. Or this histogram. So if I asked you for the shape of this, okay, we go up here, we look at our definitions. So unimodal, bimodal, multimodal, or uniform. Okay. So can somebody tell me what they think? You can just put in the chat if you want to, or you could say it. But which shape do you feel that this graph best illustrates? Is it unimodal, multimodal, bimodal, or uniform? Unimodal. Good. Okay. Absolutely. Nice, nice. Good job. Good job. So this is certainly a unimodal graph. Okay. So can everybody see that there's one distinct peak right here in the class 20 to 30? Okay, and that's how we know it's unimodal. Okay, nice job. Okay, now if I ask you for the center of this graph, okay, would you guys suggest that it's skewed left? Would you suggest it's skewed right, or would you say it's normal? Okay, so can a few people let me know in the chat what they think? Normal, normal, no. Okay, y'all are too smart. Y'all jumped on that normal train. Good job. All right. It's definitely a normal graph, okay? And for those of you that have seen statistics before, you can kind of see that this almost looks like a normal distribution, doesn't it? Like that sort of bell-shaped curve. It's just got a few more jaggies in it, okay? Now, for the spread, it doesn't look like to me that there's any gaps in the data, okay? It looks like that the data is kind of compact. And so what you would say for the spread is you would say that there are no outliers in the data. Later in the course, I'm going to show you all a more scientific way to be able to define what an outlier is. But for right now, we're just kind of doing this by inspection, by looking at graphs. Okay. All right. Any questions about that, folks? Pretty easy, right? You just look at the graph, you go up to these definitions, and it seems like the large majority of you are really good with this. Okay. So questions before I ask you guys to do a few more of these? Okay. All right, folks. So what I'd like for you guys to do is take about 2 or 3 minutes, okay, and see if you guys can identify the shape, center, and spread of these two graphs. All right. And then what I'll do is after a couple minutes, we'll reconvene and I'll just ask you all what you think. I think the first of these two graphs is not as difficult as the second of the two, okay? And realistically, I think it depends on your interpretation for that second graph, this one here, as to what the shape, center, and spread might be. All right, so for the shape of this one, okay, can a few people put in the chat what they think the shape of this one might be? And remember, shapes are either so we have a bimodal, a bimodal, a bimodal, a bimodal, question mark bimodal. So Heidi, you're absolutely correct. Indeed, everybody else is correct. It is indeed bimodal. Okay. Can everybody see that there's a significant peak right here in class 0 to 50? And then there's another significant peak right here at 150 to 200. Okay. When I think about a significant peak, I think about like riding my bike, and anytime like I have to go up the hill significantly, or if you're riding a skateboard, or if you're skiing or something like that, or if you're even walking, okay? Think of like these things as like walls, and if it's difficult to get over that, it's probably a peak in the data, okay? So hopefully that helps out a little bit for you all to be able to identify what's bimodal versus what's unimodal, etc. Okay. All right. Center of the graph. Okay. What do you all think for this one? Do you think it's skewed left, skewed right, or normal? Okay. And I think most of you can see that it's not normal. All right. But so skewed right, skewed left, skewed right, skewed right, skewed right. Okay. So for this one, it is indeed skewed to the right because remember, it's backwards. So skewed right is where most of the data occurs on the left. Okay, so this is the one that's a little bit weird. Okay, so indeed, this one is going to be skewed to the right because more of the data is on the left. Good. Okay, and then finally for the spread. Okay, would you guys say that there's no outliers in this, or do you all think that there are some outliers with respect to this graph? So no outlier, yeah. Good stuff. So there is no outlier in this data. Good. All right. And this is exactly what I'm going to ask you guys on the homework and exactly what I'm going to ask you on your first exam in a few weeks. Okay, so pretty easy, right, folks? Okay, just making sure that we have our terms down. Okay, now this last graph is a little bit nastier with respect to trying to identify, especially because of this animal right here. Okay, but let's see what we can do with this. So I'm interested in what you all think. So what do you all think about the shape of this thing? Do you think it's unimodal, bimodal, multimodal, or uniform? Okay, so Tyler, you think it's uniform? Uniform question mark. I like the cautious optimism with the question mark. Okay, for those of you though that responded uniform, it is indeed uniform. Okay, there's no real significant peaks in the data. And usually if we have an observation like this animal in 700 to 800, we just ignore that, okay? We just pretend it doesn't exist. So yeah, this guy, a statistician would say it's uniform, all right? When you give me your answers, if you give me a convincing argument as to why it might be skewed to the right, since there's more data on the left, then yeah, you could give me that argument for the center of this, okay? And in fact, you would say that for this, okay? So I think everybody can clearly see that there's more data on the left side of this graph, okay? All right, and then finally for the spread, okay, what do you folks think? Do you think that there's an outlier here or there's no outlier? Okay, so we have somebody says an outlier, Tyler, and then, yeah, that is correct, okay? There is an outlier right here Okay, because what you could do is you can clearly see there's a gap in the data right here at 6 to 700. Okay, so what you would say is that there's an outlier present. And then if you wanted to, you could define which class or classes that these outlier or outliers occur in. So I want to say class 700 to 800. Okay. All right, folks. So before we finish up with this shape, center, and spread, any questions I could answer, okay, for you all about how to define the shape, center, and spread of a histogram? Okay, nice. All right, folks. So the last thing I'd like to do is I'd like to apply everything here. Okay. I might not work through all of these. In fact, what I might do is I might just do like one set of data just to kind of remind you all of how some of this stuff goes. All right. But I do want to make sure that we have another example, so that way when you finish up quiz number 2, or quiz number 1, excuse me, that you guys are able to do this. Okay, so let's say for some reason we had a cohort study and it was conducted to aim if prolonged exposure to violent video games reduces empathy. Okay, so if you're shooting a bunch of people in Call of Duty Black Ops, does that make you less empathetic than somebody else that doesn't necessarily shoot a bunch of people in Call of Duty? So what happened was we took 100 people that had never played video games before. They were selected to participate in the study. And those subjects were administered an initial empathy test that could be scored on a scale of 0 to 30, with 0 being the lowest possible score of empathy and 30 being the highest. The subjects were then asked to play violent video games. All right. Oh, yeah, sure. And by the way, Matthew, I am recording this. So what you could do is if you wanted to go back through, you could just watch the video to be able to get this. Okay. But to be able to get the answers just in case you miss them. Okay. So, but yeah, I'm certainly happy to scroll back up through there. Okay. Sure. And by the way, what I'll do is I'll post the link in the announcements once I'm done with this. Okay. So that way you guys have it. Okay. All right. So then people were playing the violent video games for 2 hours a day, 4 days a week. All right. Hopefully they were getting paid to do that. And then each week the subjects were administered the empathy test. Okay. And the results were recorded. So then a cluster sample was taken to derive the observations that constitute the results. Okay. And then we have the scores here below. Okay. And just for clarity, these are not paired samples. Okay. Paired sample means that this 5 is associated with this 3, and this 5 is associated with this 4. They're not paired samples. Okay. They're just random selections. Okay. All right. So folks, what I'm going to do is I'm just going to go ahead and construct a frequency distribution for week 0. And then I'll construct a histogram for that. And then I'll construct a dot plot for that. Okay. And then what I'll also do, folks, is I'll post the solution to all of this online. I'll post it probably in the same place where I post the link to the videos. So that way, for those of you that want to see all of it, you can. All right. But just because for, I guess, sensitivity of time, I'll only go through these 2. All right. So let's say for some reason I'm asking you all on a quiz or exam to construct a frequency distribution for this week 0 data here. Okay. Can somebody tell me, you can either do it in the chat or just tell me, what's the first thing that we need to do to construct a frequency distribution for this data right here? So think back to what we did on Wednesday, or look. Yeah, absolutely. Nice, Tyler. We need to find the sample size. Okay. Remember, we need n for this. Okay. And to get n, we just count the number of observations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. If I can count correctly. All right. And so for us, okay, hold on one sec. Gotta switch back. Gotta find my pen. Ran away. Uh-oh. What am I doing? Oh, there it is. Sorry. So much junk on my desk. So we would have that n is equal to 15 for this example. Okay, good, good, good. All right. Now, after we find the sample size, okay, the next thing that we need to do is we need to use Sturge's rule. Okay. And remember, Sturge's rule is C equals 1 plus 3.3 log of n. Okay, so that's our formula, right? And so in this case, we know that n is 15. So we get c is 1 plus 3.3 log of 15. And that's where you throw that into your calculator, okay? So if a few of you guys would be so kind as to throw that in your calculator, and then just let me know in the chat to 3 decimal places what you get, and I'm going to do the same thing just to make sure we're all okay with this. So log 15, okay? And then, okay, Lily, you got 4.8. Emma, you got the same thing. I got the same thing too. So we're either all right or we're all wrong. And I'm going to go with all right with this. Okay, so thank you all. Appreciate that. All right. Now, 4.881, that tells us that we should have approximately 5 classes, right? Because remember, C just tells us the number of classes. So this is about 5 classes, okay, for our data. Okay. Of course, that doesn't tell us the width. And so the other formula that we need is width is equal to high minus low divided by C, okay? And when you guys are doing your quizzes, okay, and when your examinations, you want to make sure you have these formulas present, okay? So I'm not going to ask you guys to memorize any of the formulas, okay? You just want to make sure you have them written down and accessible, okay? So in this case, and if you guys can correct me if I'm wrong, okay, the highest observation looks to be 28. Okay, so if we go back to our list of observations, the rightmost number is 28. It seems like the lowest number is 5. And then C, we're just going to pull that from the 4.881 that we all just found. Okay, now don't forget, whenever you guys plug things in, make sure you put it in parentheses. And then we're just going to approximate this. Okay, so similar to the to C, if a few of you guys can compute that, okay, and I'll do it as well just to make sure we're all on the same page. And then once you get a value for W, if you can let me know what you get, just put it in the chat for me, please and thank you. All right, so 4.712. Okay. Let's see. Oh, you know what? Missed an 8. Boy, I'm glad you put that in the chat, Emily, because I actually missed an 8 when I did this. So I put 4.81. So I was going to have like 4.77. So thank you. So that's why I'm so glad you guys checked these out just to make sure we're all okay. So when I checked it, I got the same thing. So thank you. Good job. All right. So 4.712. And then at this point, what we'd like to do is we'd like to round it to the nearest integer. Okay. So I'm going to round this up to 5. Okay. Remember your rounding rules? You just look at the number that's to the right of the decimal point. If that number is 5 or greater, you round up, okay? So this tells us that we have a width of 5 for our frequency distribution, okay? So everybody good with that, folks? Any questions about how we got 5 for the width, okay? Just using these formulas, okay? All right, folks. So now what we're going to do is we're going to construct our frequency distribution. Okay? And so remember, 4 columns for our frequency distribution. We have our class, which is the hardest one to set up. Once we have the classes, the rest of the frequency, and I'm just going to say the relative frequency, I'll just say RF, and then CF, just to abbreviate it, okay? All right, now for the first class, okay, and the first class is always the hardest one. Remember that we had the width was equal to 5. Okay, so don't forget that because that's going to be important. We need that to go any further. The first class, we start at the number 5 because that was the lowest observation. Okay, so really quickly, I just want to make sure that everybody understands that we're starting at 5 because of this number right here, this 5. Okay. We're not starting at 5 because the width is 5. That's just a complete uncanny coincidence that it works out that way. Okay. All right. So just making sure that we're aware of why we put the lowest bound as 5. Okay. All right. So now we're going to count up 5 to get to our upper bound of the class. And so for the class, we have 5. So we're going to count 5. 1, 5, 6, 7, 8, 9. Okay. So our upper bound for the first class is 9. Okay. Does that make sense to everybody how we get that? Any questions I can answer about how to get the upper bound? Okay. For the next one, we start the class at 10, and then we're going to count 10, 11, 12, 13, 14. So that's 5. Okay, so we go up to 14. And then the next one we would have 15. So 15, 16, 17, 18, 19. That has a width of 5. And then I think from here, once you have 3 of them down, you can start seeing the pattern really easily, I believe. Okay, so for the next one, we have 20 to 24. Then we have 25 to 29. All right. And I know what's going through some of your heads is that, well, Chris, the highest observation we have is 28. Well, that doesn't matter. We don't want to stop at 28. Okay. We want to always go up to the highest width of the class. Okay. So even though 28 is the highest observation we have, still you have to keep those classes even. Okay. In other words, you have to keep them at 5 for each of them. Okay. So before I go through and complete the rest of this frequency distribution, are there any questions about the classes? Okay, that's usually the hardest part for folks. Once they get that, then the rest of it's pretty easy. All right, friends. So for frequency, and if you guys can verify this for me, I think I see 4 observations that are between 5 and 9. Okay, that would be 5, 5, 6, 8. Between 10 and 14, I see 5, I believe. All right, so I see 10, 11, 13, 13, 14. So I see 5. Between 15 and 19, I see 4, I believe. So 15, 15, 17, 18. And then I have 1 between 20 and 24. And then I have that 28. Okay, so that should be my frequency for this. Okay. And just before I go on, just to make sure, because I'm talking and I'm writing and I'm looking at 3 screens, can somebody verify that I indeed counted those correctly before we go on? Because I don't want to do anything else until did I make sure that this is okay? So did anybody get the same thing when they counted and made sure it was the same? Okay, thanks, Anna. I appreciate it. Nice. Thanks, Tyler. Good stuff. All right. So for the relative frequency, remember we know that the sample size is 15. Okay, we got that earlier when we computed C. And so our first relative frequency, 4 out of 15. Our next relative frequency, 5 out of 15. 4 out of 15, 1 out of 15, and 1 out of 15. Okay. For cumulative frequency, same thing as we've done in the past. The first relative and cumulative are always the same, so 4/15. And then remember, folks, we add these together. Okay, so we take 4 and 5 and we get 9/15. Then we add 9 to 4 and we get 13/15. Then we add 13 to 1, we get 14/15. And then finally 15/15. Okay, that might be the worst 5 I think you guys might have ever seen in your life. They make that look like a real 5, especially since it's being recorded. Just want to make sure everybody knows that I am quasi-literate. Okay. All right. So that's our frequency distribution, right, folks? Okay. So we're getting good at this. We've seen it plenty of times. The hardest part, again, just making sure we get these classes correct using Sturge's rule. Okay. Questions I can answer for y'all about going through and getting the frequency distribution for this quantitative data. Okay. All right, friends. From here, we're just going to go ahead and use what we have to construct a histogram. So this is part A. I'm skipping part B just so that we can kind of go on. For part C, if I construct a histogram, okay, the highest observation I think we had was 5. Okay, so I'm just going to go up in increments of 1. Okay, 5, 4, 3, 2, 1. This is our frequency. Okay. And then our classes, I like to draw the bars first. And so you might remember that we had 4 observations in that first class. Then I think we had 5. And then I think we had 4 again. And then I believe we had 1 and 1. And I might have to make this a little bit larger, like that. Okay. Let me erase this. All right. Now I can go ahead and start filling in the classes. Okay. So you folks probably remember that this one was what? 5 to 9 was this class. And then 10 to 14, and then 15 to 19, and then 20 to 24, and then 25 to 29. Right, folks? Right. Now remember, these were the week 0 scores. Okay. And if I wanted to title this graph, these were the responses to the empathy for the week 0 score. Okay, so we could just say something to the effect of responses to empathy survey for week 0 participants. Okay, or something like that. Okay, and I'm pretty loose with respect to, you know, how you guys are going to do this. Okay, so if you just put like, you know, scores on tests or something like that, that's fine. Okay, but as you guys go higher and higher in your academic careers, what you're going to learn is that it's more useful to be more specific than less specific. Okay, especially for people that don't necessarily know what your study entails. Okay. All right, folks. Any questions I can answer for you all? Okay, and I'm going to check the chat just to make sure I haven't missed anything. But any questions I can answer for folks so far about any of this business with respect to our histogram? Okay. Last thing we're going to do is we're going to make the dot plot. And fortunately, the dot plot doesn't require the frequency distribution. We just go ahead and plot. All right, so I'm just going to make a number line here. I'm going to go ahead and say 5, 10, 15, 20, 25, and 30. All right. If you wanted to do increments of 10, that's perfectly fine. Okay. Just be wary, though, that the wider you make your intervals, the less precise that your line's going to be. Okay. So you just want to make sure that you're in the middle to where it's not so taxing that it takes you 20 minutes to do this. But at the same time, you know, people know the difference between a 5 and a 9. Okay. All right. When I'm making my dot plot for this, I'm just going to stack 2 5s, right? Because we have 2 observations of 5. We have a 6. So I'm going to put that here. We have an 8. And then we have a 10. We have an 11. We have 2 13s. Okay. We have a 14 and 2 15s. Right. A 17, 18, 22. So we have a 17, an 18, and a 22 over here. And then a 28 all the way out here. Okay. All right. Oh, and I will go back and I will get the shape, center, and spread of these in a second. Okay. But I just want to make sure that we get the dot plot and the histogram done. Okay, so this is our dot plot, and remember, this is the week 0 scores on our empathy test. Okay. All right. So any questions I can answer for you all about how to construct the dot plot for this? Okay. I'm assuming, you know, you guys would love to see an examination full of dot plots. That would be awesome, right? Okay. Let me go back, and I'm going to ask you all to help me out with the shape, center, and spread of this histogram. Okay. So just take a moment, okay, and think about what you perceive to be the shape, center, and spread of this thing. And then I'll ask you all what you think about it. Okay. So, and remember, shape is the modality. So unimodal, bimodal, multimodal, or uniform. Center, either skewed left, skewed right, or uniform. And then finally, spread refers to if there's an outlier or if there's not an outlier. Okay. All right, folks. So for the shape, center, and spread of this histogram, all right, let me erase some of this stuff. Well, I guess we could just write it on the next page. Okay. Can somebody tell me what they think about the shape of the previous histogram that we were just looking at, this animal right here? Okay, so you guys think it's uniform, multimodal, bimodal, uniform, or unimodal, unimodal. Yeah, okay, unimodal it is. Okay, so thank you to everybody that correctly answered in the chat. All right, good stuff. All right, center for this animal. Okay, what do you all think? Do you think this is skewed right, skewed left, or normal? All right, so go ahead and put in the chat what you all think about that. Skewed right, skewed right, skewed right, skewed right, skewed right, skewed right. Nice. All right. So if 7 people think it's skewed right, it's most likely skewed right. All right. So for our shape, for our center, excuse me, it is going to be skewed to the right because there's more data on the left than anything else. And then finally, folks, for the spread, okay. What do you think about, is there an outlier present or is there no outliers for this histogram? No outlier, no outlier. I'm going to say the same, that there are no outliers. Thanks to everybody that responded. Okay, so there are no outliers. I promise I can spell. There was an I that I weaseled my way in there. So nice. Okay. All right, folks. Any questions I can answer about shape, center, and spread of a histogram? It seems like you guys got that down pat, like really solid. Okay. One last thing is that what we notice is that, and I know there's a question G down here, and G says, suppose somebody makes the claim that based on the data, prolonged exposure to violent video games decreases one's empathy. All right. Similar to, and I can't remember who said it, but on Wednesday, I asked the same question, and I think somebody brought up the point of the sample size. And I think the exact same thing applies here, is that you can't imply causation because we only have 15 observations. Okay, so I just want to make one final note before we move on from this. Okay, so a final note. Okay, in fact, I'm going to type this instead of writing it so that way you guys don't have to suffer through my terrible handwriting. Always consider the sample size. Okay, so remember that there are only 15 observations in this study. To draw any conclusions would not be a good idea, okay, or would not necessarily, let's say not necessarily lead to valid conclusions, since we should have more data. Okay. All right. So folks, every time that you all are going through and doing a study of any sort of type, okay, you always want to make sure that you have a sufficient number of samples to reflect your population. All right. If you think of all the people that play violent video games around the world, I mean, we're talking in the millions, right, folks? And to have 15 observations or 15 people represent millions is certainly not going to lead to the true outcome. Okay, we probably need a few thousand people. A question some of you might have is, what is a sufficient number of samples to get? Okay, there's no hard answer to that question. All right, and the reason being is because there's a lot of different populations and there's a lot of variation in populations. Okay, there's underlying factors, like for instance, age. Okay, people that play violent video games in their younger years might develop less empathy because they're still forming their own basis of identity. Okay, whereas somebody that's the large majority of this class, you all are between the ages of like 18, 22 for the most part. Okay, for the most part, you've really solidified what your identity and what your values are. Okay, where somebody that's like 4, 5, 6 years old, they haven't necessarily thought about those things. So when we're talking about sample sizes, it's one of those things where you can't put a hard and fast number on. Okay, there are formulas that we're going to look at later in the course. Okay, for sufficient sample sizes to be within 95% certainty or 99% certainty of a true mean, but we'll look at those later. Okay, so for any of you that might need this for other courses or for other research, let me know and I'm happy to show you guys those formulas. Okay. All right, folks. So the last thing I want to do this morning is I want to go through and just talk a little bit about Microsoft Forms. So that way, for those of you that are thinking about getting your capstone projects together, that you can try to get this, you can start getting a survey together and start thinking about what surveys might be. Okay, so let me switch really quickly to, to this. Okay. And I'm going to go to, all right. So for you all to access Microsoft Forms, okay, so what you're going to do is you're just going to go to ALNet and you're going to go to your Microsoft Office 360. Okay, so, and you can either follow along with me or not. Like I said, this is being recorded, so you don't have to follow along like on your computer, because then you might have to do like, 2 screens at once or something like that. Okay, but I'm just going to go ahead and I'm going to log out of my email really quickly. So, so let me log out real quick. Sign out. There we go. So sorry about that. And then usually when you sign in, so here's how I get there. Okay. I just go all the way to the bottom of the Harvard homepage, and then I just click on like AlMail. And then if you click there, and hopefully it brings me up to the screen that I want. Maybe it'll do it today. Okay. And just to verify, when you guys log into your AlMail, is this like a similar landing page to what you all get? So can somebody let me know in the chat if that's like you guys can get to this screen from your login, or if you guys have never seen this screen before? Okay, cool. Thanks, Heidi. Appreciate it. Thanks, Lily. Okay. If you, by the way, for those of you that have trouble being able to get here, you can either hang out afterwards or you can just set up an appointment with me. Remember, I do have a student hour virtually right after this class. So folks that want to hang on and get a little bit of help with some of this stuff, I'm happy to do that. Okay. Now, what you're going to do is to get to Microsoft Forms, okay, you can just go ahead and click in this upper left-hand box if it doesn't show up down here, or you can click down here on the 3 dots, okay? If you click up here, it'll bring up all the apps, okay? I'm just going to say Microsoft Forms, okay? And what it'll do is it'll bring up a whole, like you guys might not have anything in here. I have a whole bunch of stuff, okay, just because I made a bunch of forms and things like that, all right? And what you're going to do is to create a new form, you're just going to click on this down arrow and click new form. All right. And then what you could do is you could type in what the title is. Okay, so I'm just going to say this is my Math 216 survey. Okay. Because what I'm going to do is I'm going to survey you all. Okay, just really quickly. And then you can put a description in here. Right. And then down here, you can construct your questions. Okay, now I'm going to get rid of that one. And you can either do a multiple choice, or you can do an open-ended or a rating or something like that. Okay, so let's say for some reason I want to ask you guys a question or two. Okay, so a question I'll ask you is, do you like fries or chicken tenders better? All right. And I'm going to let you guys reply to this in a few moments. Okay, so fries, and nope, not maybe, tenders. All right. Then I can go ahead and add another question. Okay, and I'm going to make this one an open response question. Right. And let me say something to the effect of, what is your major? Because I want to see if there's a correlation or an association between what your major is and if you like fries or tenders better. All right, maybe for some reason I'm sick like that, and that's what I want to do. Okay. Now, once you've done this, okay, let me blow up the screen a little bit. What you folks are going to do is you're going to collect the responses. And it's going to give you the link. Okay, I always click on shorten the link because why not? Okay. And what I'm going to do is copy this. And this is where you guys can go ahead and either drop it in an email or a chat or post it on social media or something of that nature. Okay. Now, what I'm going to do is I'm going to post this in the chat. Okay. And hopefully it came up. And what I'd like for you guys to do is to go into the chat and just take the survey really quickly, because I'm going to show you what you can do once you've collected the data. Okay. And I'm going to go ahead and take it myself. All right. So I'm going to click on my form, hopefully. And by the way, if for some reason when you click on it, it doesn't come up right away, you might have to cut and paste it into your into a URL. Okay. I clicked it 3 times, so now it came up 3 times. All right, and it's asking me to sign into my account, which is kind of bogus because I'm already signed into my account. All right, so I'll sign into my account again. Thanks a lot. I have to sign into my own account to take my own survey. Oh, now I have to do the duo check. Oh. Any other barriers they want to put up with me today? All right. So, believe it or not, I like fries better. I'm one of those sick animals that likes fries. And my major is math. I was also a computer science major, so I'll say math. Computer science, good enough. Okay. And then I'll submit. All right. And then my response was submitted. Okay. And you all obviously did this a lot quicker than I did. Okay. So I'll give everybody just another minute or two to finish out this life-altering survey. All right. But for those of you that have ever worked with like Google Forms or Microsoft Forms, one of the benefits of working with Microsoft Forms and Google Forms, as opposed to like SurveyMonkey or something like that, is that you don't have to pay to be able to access the individual responses. Okay, and I'll show you what I mean by this. Okay, so you can clearly see right here in the upper right-hand corner, there's this responses 14. Okay, that means 14 people have responded. So I'm going to click here. Okay, and it's going to show me a really quick synopsis. Oh, wow. I was actually thinking that more people would like tenders than fries. So I am absolutely shocked. So thank you for enlightening me today. So, and then down here, it'll show a pretty brief synopsis of what the majors are. Obviously, the words that are bigger are going to be more responses. Okay. Oh, cool. 2 people are biotech folks. So nice. Professor Madden and Professor Martin. Love y'all. Okay. Now, when you guys are doing your capstone projects, what you probably want to do is you want to go into Excel. Okay. And I'm going to open this up in Excel. And next week, I am going to show you guys how to work through Excel to be able to summarize data. So it's opening, I think, maybe, possibly, potentially. All right. Oh, here it is. I'm so impatient that I click I always click it like 3 times. Okay. And check this, folks. What it does is it puts it really nicely into a summary for you all. Okay. And then there are options to where you can make it into, you can make it anonymous so that way you don't see it. But of course, let's say for some reason we wanted to just sort of sort this data. Okay, so what I could do is I could go ahead, I could highlight all the data, and then I could sort it based on, if I like fries or tenders better. So I'm going to sort it. Nope, not by name, but do you like fries or tenders? And then what it'll do is it'll put all the folks that replied fries, and then all. So you can clearly see the power of utilizing this Microsoft Forms to be able to collect data. Okay. All right, so pretty cool, right, folks? Nice and easy. I'm assuming a lot of you have done this before, all right? But for those of you guys that haven't, this is just how you go through and you can try to collect some responses using a Microsoft Forms survey, all right? Now, later in the course, like I said earlier, what we're going to do is we are going to be getting data for our capstone projects, okay? All right, so I think that's everything that I wanted to go through and illustrate today. Okay, so before we conclude, does anybody have any questions about anything with respect to what we did for the data today with respect to the shape, center, and spread, histograms, box, the dot plot, stem and leaf plot, those things? Okay, I'm going to stop recording.